Welcome everyone to this Hasura community call today. My name is Rob Dominguez. I'm a senior engineer here at Hasura. This is our 48th community call. This is for January 2025. We're very happy to have you here with us today. Let me go ahead and jump into our agenda real quick. As always, we have a packed agenda for you. The focus of this call in the beginning is going to be on looking at retrieval augmented generation benchmarks and how PromptQL is performing close to 100% on that. And then we'll dive into some more product updates that come along with that as well. We have some familiar faces on the call today as well, but we're always curious where all of you folks are joining us from. So over on the right-hand side, you'll see an engagement section that has a chat option. Go ahead and drop in the chat for us where you're joining from, what your name is. We'd love to learn a little bit more about you and see what kind of representation we have from kind of all over the place here. Additionally, we have some cool features within this platform that allow us to do Q&A. So we can actually bring up the questions on the stage when we have the presenters come on. So in that engagement section, you'll see a Q&A option. So if you do have any questions throughout the presentations themselves today, please throw those inside of the Q&A section and we can make sure that they get answered and that you get your feedback directly. All right. With that, I think we're going to go ahead and jump into our first topic here. We have a guest who is very familiar to the show, Tiru, who's going to join us to talk a little bit about this RAG benchmark and Hasura PromptQL's performance on it. So Tiru, want to go ahead and join me up on the stage here, please? Yeah, so when we say, I've been looking at the docs that we have and the notes that we have on the PromptQL site, and I see that little tilde for, about 100%. How close are we getting to 100% with this?
Well, it depends on the size of data that you compare to the benchmark on. Like if you take 1,000 questions, it's about 100%. But if you take a reasonable set and actually analyze each and every question, how it's performed and why something is failing or not, which is about we tried a bunch of sets. Like we can take the hardest 10 questions, or we can take 50 questions of different sorts. So I'll be talking about that and the actual numbers as well.
Excellent. All right, I'm going to get out of the way and let you take it on.
All right, folks. So as Rob already introduced, we're going to talk about how we can achieve, or can we achieve 100% on a RAG benchmark. So those of you who are new to the AI space and might be wondering what RAG is. So RAG stands for Retrieval Augmented Generation. Which is kind of like a short concept where you kind of get external data or augment the question that you have with external data and combine it, basically augment your question with that data and then ask the LLM to give you an answer. And you need to do this usually because LLM is not trained on, say, private data or data that you think is very specific to your domain. So instead of hoping that it gives answer on something that is not at all trained on, you would rather just give it that context directly into the prompt and try to get an answer. So what is this benchmark? We're talking about getting 100%. So understanding the benchmark is really important. So this benchmark is called Frames. This is something that was released mid to late last year by Google. It stands for Factuality, Retrieval, and Reasoning Measurement Set. It has about 800 questions on the Wikipedia domain. So ideally, all questions which are in frames can be answered by looking at some articles actually on Wikipedia, and the questions are very interesting, right? It's not straightforward, asking for a simple fact. There's a lot of reasoning involved. It involves reasoning over multiple articles and so on and so forth. So it's a complex benchmark. So many of you might have heard of DeepSeek, which is causing the waves right now in the AI world. And DeepSeek also published their results on Frames here, along with other popular LLMs. And we can see that Frames the results are not bad for any of the LLMs, but it's not near 100% as well. So this shows that Frames is a relatively difficult benchmark, and also something that LLMs are looking at to solve or evaluate against. So how did we evaluate this benchmark. So a little bit of like context on the setup is crucial for you to understand how we did it. Frames paper actually does not describe uh, the setup very clearly. So you might have to like do your own setup, but the important fact is that you use the same setup across each of the LLMs, right? So the setup remains the same, and the LLM keeps changing. So that makes it fair. So the way that we did it was fetching the Wikipedia data, like directly scraping it off, and then doing a parsing. All that is available in this repo, in this code as well. Then we did a vectorizing of the title of each article, and then stored it in Postgres. And in Postgres, you can use PG vector to like store vectors. We also tried just vectorizing the entire content itself instead of the title, but that did not do well in any of the benchmarks. So I think using the strategy of vectorizing the title seems to be generally much better. Then we have to create a function which can fetch like the top K articles given a user query, right? So it will basically do a vector search, do some scoring, and retrieve the top 5. Now, once you have such a function, you can add it as a tool in a RAG program, right? So tool is another AI concept. It's given by most AI services where apart from like just giving the prompt, you can also give a bunch of tools which the program can choose to run it if it's required, right? The same thing can be just the same function as it is can be added as a command in PromptQL or in Hasura. If you use Hasura, you might be familiar with the concept of commands. So you add that as a command, and the tool functionality or the search functionality is same across all these different programs. So the first thing that we compared against was how did this benchmark perform on naive RAG. So what is naive RAG? As I mentioned in the beginning, like basically when you give a user prompt, it would first do a semantic search, maybe retrieve like top 5 articles. It will combine the user prompt and the articles in the prompt. Just like the question will be the first line, and then all the retrieved content would be the subsequent line. And then it will just ask it will give that to the LLM and ask for a response. As simple as this, right? So this is the naive RAG setup. So it's only doing semantic search once. So frames is going to perform poorly on this by design because all the questions are meant to be like multi-hop, and I don't think there's even one question which can be answered by just one article. Uh, and then the questions are not it's not very explicit, right? Like what data you want from which article and so on. So there is an interdependency, so you can't pre-retrieve all the information in one shot for a given question. uh, you need to use something, you need to calculate something in the first article to then do a subsequent search for other articles. This is where agentic RAG comes in. This is a kind of a new phrase, but still, I think quite popular already. Which is that instead of doing this one-shot kind of retrieval, we make the LLM itself decide when to call the search function and how many times ever also, right? Like, so if you look at this flow here. So when you give the user prompt to the LLM, and this is where tool calling functionality in the LLM helps you like implement this easily. So whenever you give a user prompt to the LLM will decide, oh, does it need some information to answer this question? And if it's yes, then it calls that semantic search function, which gets you the top 5 articles, gives it back to the LLM, and the LLM decides as a next step, does it need even more info, right? And if it's yes, then that goes again, the whole cycle repeats. It will get the new information, augment that again, so on and so forth, right? At some point, it will say, okay, I think this is enough, and it will generate the final answer. So this is agentic RAG. Agentic because the decision to ask for more data or retrieve more data is done by the LLM itself. So this was agentic RAG. So let's look at how this basic setup works with PromptQL, right? So we give the question as it is from the frames benchmark to a naive RAG setup, to an agentic RAG setup, and to a PromptQL setup. We used around 50 questions for this one. Naive RAG actually around like 4 or 5, and it's not showing up here. Agentic RAG was around like, I think around 41, 42. And PromptQL was hitting around 50, right? This is what was happening. And it's not very surprising, right? Because what agentic RAG is doing is probably the best thing that you could also think of doing, right? And PromptQL only slightly improves on this setup because of the way that it stores the retrieved data and how it extracts information and so on. But the overall logic is not very different, right? Especially if the context size is not too large. For example, it's only retrieving like two, 3 articles from Wikipedia, so on. There's not going to be like much difference in calculation. So this is what happens. So what is this about? Like, we are here to like understand how to get this to 100%. So how do we do that, right? So first, let's look at the frames questions itself. So here's a sample of frames questions. Uh, the first one looks like, reads like a complicated puzzle. If my future wife has the same first name as the 15th First Lady of the United States mother, and her surname is the same as the second assassinated president's mother's maiden name, what is my future wife's name? Wow, like it's very hard to like parse something like this itself, right? Let alone like ask LLM to like retrieve related data and give an answer. The second and third question are also similar. The third question is slightly more straightforward, I think. As of 2023, how many more employees does the company, which is alphabetically the first by ticker symbol, have than the company which is alphabetically second to last by ticker symbol? Still a little bit of a puzzle like nature, but more straightforward, I think. So LLM already has this concept of like thinking and creating like a chain of thought. So whenever we give this question to the agentic RAG system or to PromptQL, it obviously does some thinking and figures out a plan to like execute it. But obviously that is falling short. We are only hitting like 40 to 50%. So we thought of saying, okay, let's give this question like a better prompt, which is more realistic, which is what a human being in an enterprise or anywhere would actually describe uh, this task as. Nobody is going to ask questions in such a complicated and intertwined manner. They're probably going to ask it in simpler phrases, right? So, for example, for that third question that we saw, you might give an explicit plan, which looks like, okay, for this question, use this plan. Like find the article that contains the S&P 500 list, then get the company name of the alphabetically first ticker from the article, then get the company name of the alphabetically second to the last ticker, and then get articles about these two companies and get the employee count, right? So this complicated question, and rather like a very puzzle-like question, we have just broken that into into an explicit plan. And then we thought, okay, let's see if this removes the kind of, let's say, the plan component of the LLM. If it removes that, and is it then able to like answer from the retrieved data, right? That was the intent. So here, what we did was give, like for each question, we give a plan. So this whole thing becomes like the prompt. And then we give it to both the agentic RAG setup and also to PromptQL setup. And this is where the magic comes in, right? When we use this, when you use the top 10 hardest questions that we found in the set of like 200 that we sampled, like the hardest 10, we got around 100. In the top, with a set of like 50 questions, we got like 98% accuracy, and so on, right? Uh, and agentic RAG with plans is somewhere around 60 percentage. And this is the way to get from like 50 40 to 50% to like 100%. Just give it some reasonable plan and hope that the LLM or your system is going to like be able to like follow that plan accurately. PromptQL does that accurately, as can be evidenced, but agentic RAG still falls short, even though both PromptQL and the agentic RAG setup are using the same LLM. Agentic RAG is not able to follow the plan or execute the plan in a reliable way. So that's where we come to like why is this happening, right? Why is the agentic RAG not able to do accurate plan following and accurate execution of the plan? So let's do a quick discussion on the various cases why agentic RAG falls short. Now, if you look at the failure modes here, right? One of the most common things that we saw was there was extraction errors in processing, which means that if you give a question like this, do some thinking, it'll say all the right things, except it'll get the actual fact of it wrong. So it says like here your future wife's name is going to be Eliza Balu, but that is the wrong answer. The right answer is Jane Balu, right? And what happened here was because there's so much data in context, right? Trying to extract something which is very similar, like for example, uh, it extracted like the 16th first lady's name instead of the 15th first lady. That is probably because they are very close to each other and whatnot, and the context is already very huge, and there might be like repetitions of the same names here and there. So it's basically very unreliable to extract something very specific from a large context window, right? So that's one of the reasons why extraction fails, and hence the subsequent query fails. With PromptQL, the way extract happens is in a completely different context. There is a smaller like the context size for whatever needs to be extracted is separate from the rest of the context of whatever has happened so far, right? So the context size is smaller. It's able to extract much better using that method. The second is, although this was we like excluded most of these cases from the sample set that we used, but we still kept one or two just for illustrative purposes, is context size limitations itself, right? So with we are using Anthropic Sonnet here, and for few of the questions like this one, it had to retrieve like 3-4 articles and hence exceeded the context size. Then we look at one of the more, in my opinion, the most common error when using context size computation is in inexhaustive computation. What does that mean? So if you look at a question like this, which is basically like asking how many people had walked on the moon as of the first model year of the vehicle. So if there are multiple answers, like if there are like different parts to the answer and then you have to collate the answer as a whole, the LLM is actually generally very quick to like answer as soon as possible, right? So usually it answers like only 2 people have walked on the moon, although there are 4 people because they were like 2 different missions with 2 people each. But what the LLM usually does is, as soon as it has got some inkling of an answer, it's very quick to like just respond with that and not finish the whole. It does not like do like a proofread of its solution and check if it's done things exhaustively. This is where PromptQL again shines, because PromptQL is designing like a plan for this and it's executing the plan more precisely. So it's not stopping midway whenever it feels like it has got some answer or something that resembles the answer. It's actually computing the whole thing according to the query plan and then finally giving it answer, right? Um, And finally, the usual issue with LLMs is like it cannot compute things properly, right? It doesn't have a mathematical or computational engine. Uh, so hence, like few questions go wrong there. But with PromptQL, you do have a computation engine, so these things don't happen. So these are the reasons because of which we are able to achieve like 100% on a subset of the frames questions. We would love if you could try it out on your own setup, bring your own unstructured data, vectorize it however you want. It's like few clicks, a few commands to like get it set up with PromptQL and to start using it. So with that, I will stop and take any questions in the chat.
Awesome, Tiru. Thank you so much. So we do have one question that's over here in the Q&A section already, which I think Harsha is going to put up on the screen for us so everybody can see it down below. It's a little bit long, so I'm going to go ahead and start reading it out loud. It says, if I understand what you're adding to the context in this flow is the whole Wikipedia article, why not chunk the article and only search part of it to reduce context size?
Yeah. So the two reasons for that. The first reason was we did try that, and across all the systems, the results were very poor, and that is actually a good indication of the frames benchmark that it needs chunks which are like spread across here and there, and there is interdependency and so on. So using the chunk, like small chunk strategy, did not work out in any case, right? It was poor for all the systems, and then we looked at the chunk size for Wikipedia, each article basically, and it seemed like it should be fine to like give the whole article itself to the LLM and not worry about chunking strategies and lose precision because of this artificial reason. And unless unless the number of articles explodes a lot, which like goes around 10 plus or so on, or the LLM actually does not retrieve the articles more efficiently and just like overloads the context for no reason, only then we see context size limitations. Otherwise, with just the ground truth Wikipedia articles, if you compute that, 99% questions should fit into the context.
Awesome. Very helpful as it's being said in the chat over there. And yeah, it's a lot of fun to see how context size is changing in all these LLMs as well. There's one more question in here, and I think this may come up a little bit later on when Praveen's demoing some of the product updates that we've had, but in particular, the questions around the query planning. So does it work step by step in a while loop is the question.
Yeah, so think of it as having a complete execution of a program inside. So it does have a while loop. So behind the scenes, it's a Python runtime, right? So everything is happening inside, and there is like interfacing with something that we call memory artifacts and AI primitives and so on. So it's like a whole runtime of like executing a plan reliably.
Awesome. I've got one more ask for you on your way out as you go backstage. Somebody's asking for the getting started for the PromptQL docs. So if you wouldn't mind dropping that in the chat for everybody so they have access to it as well and can get started themselves after this call is over. Thanks so much, Tiru.
Thanks, Rob.
If you've been interested by what Tiru has said, and then also all the things that are going to be coming up on our upcoming community calls, we do have another one that we've already planned out for February that we'd like to go ahead and plug right now. We're kind of reshaping the way that we're doing these calls. We're turning them into more of a thematic setting. So the theme of our next call in February is going to be on making your AI think before doing, which is a big topic for what Tiru has just talked about. Really trying to show that these LLMs should be doing a bit of reasoning, for lack of a better term, before they actually start answering the question that you ask them. That'll be on February 27th at 9 a.m. Pacific. A couple of other things just to go ahead and plug while we're here on this part of the call as well. We have HasuraCon 25 coming up in April, and this one will be live in San Francisco in person. I believe this will be the first one that we've ever had in person before, so we're very excited about it. And you can see the theme there is enterprise AI beyond the hype. We want to make sure that everybody here, if you're a practitioner, if you're an IC, if you're really intrigued by all these things that are happening, that you pass this information along to other people inside of your organization, especially those who are in your leadership roles, so that they can come and see the value of what you see as well, and really understand how this can help transform your business. So please check this out. I'll leave the QR code up there for just a second in case anybody wants to go ahead and scan it, or you can find more information on our site at hasura.io/events. I believe that's where that takes that to. And I'll have this up at the end of the call as well. Next up, we're going to talk about product updates inside of PromptQL. As I alluded to, we're going to go ahead and bring Praveen on the stage to join me as well, please. Praveen, how are you doing?
All good, Rob. How about you?
Yeah, good. So I remember reading through the notes for things, and we are going to talk a little bit about some editable query plans, I think. So kind of linking into that question that came up earlier. But there's a lot more exciting stuff that's happening too. So I'll go ahead and jump out of the way. Let me unshare my screen and take it away.
Cool. There's plenty of updates. So I'm just going to quickly run through a few of them. Starting with editable query plans. And I think there was a question on chat as well about running query plans in a loop and whatnot. So I'm going to quickly show you what that means. So I have a customer support agent, and this is my favorite question as well. Who are the 5 most painful customers? And as usual, PromptQL starts off with creating a query plan to answer this question. And to define what painful means, it will come up with some factors here: number of support tickets, error rates, ticket response patterns, and whatnot, right? So, and let's say it had an error in the columns, it will recorrect itself to come up with the right column names and make the query again, right? And there you go. So you have the artifact of the top 5 challenging customers with the pain score. Now, if you look at the query plan here, one sec, probably went to the wrong one. Let me refresh this one. Yeah. So if you look at the query plan here, it has computed a pain score based on a few criteria. Now, let's say you're not happy with what the LLM came up with. You can just modify the query plan to say, hey, do not look at the total number of tickets, and just feel free to modify this and maybe add some other condition if you want. And you can just nudge PromptQL to say, hey, run this query plan instead with the updated criteria. And PromptQL will execute this query plan with a new set of rules, and will get the updated list of 5 customers and will recalculate the pain score as well. And essentially what's happening underneath is obviously there is a Python runtime, as Thiru mentioned, which will execute a query, and it will also make use of the LLM to do classification, and that's what's happening over here. So in this updated one, the pain score is updated without that total number of tickets that was there in the previous one. So you can keep nudging PromptQL with query plans to just tailor your response. And that's one of the core updates that we've made, more of a UI experience as well. But the idea is that you can prompt PromptQL to get the right answer. Next up is we have a few AI primitives, the latest of them being the extract primitive, and that's pretty cool as well. So for example, in this, again, the customer support example, out of all ticket information that you have, I want to extract just the tech stack that's being mentioned in all of these support tickets. So I'm going to ask hey, in the last whatever number of support tickets, look at the ticket information and extract any tech stack tooling mentioned, right? And what PromptQL will do is it will use the extract primitive to look at the ticket information of each support ticket, and then it will try to extract the tech stack tooling criteria, so which will look at for databases or tools, tech tools that will be mentioned in the ticket, right? And again, it will recorrect if there are issues with the schema. Looks like the timestamp error with this particular one. Now, it will use the AI extract function to identify the tech stack, so we can look at how the response looks like. And here we can see that the technologies are are created here. So you can see their name Postgres and the category be database. GraphQL here, there's Hasura here. So this gives you like a good way to like extract specific kinds of information from like unstructured data. This is just ticket information, which is just raw text, right? So you could ask for specific categorization or extract specific tooling information from this one. Opens up lots of use cases. So this is pretty cool. And from execution of this, right? Going back to this, the extraction that's happening over here, it's also parallel, running in parallel. So if there are 10 items which are being extracted, there are 10 different items running in parallel, which makes this much faster to execute. Previously, we were doing this sequentially. So now this is done in parallel. So you can expand the number of items that you are processing for either classification or summarization or extraction. So all of the primitives will now run in parallel for faster execution, right? So that's what parallel runs. And of course, we are, again, constantly improving error handling and we've increased timeouts wherever possible. Next up is the program API endpoint. And for this, I have a example workflow to showcase where I have a GitHub repo, and I wanted to just automate labeling of issues as and when somebody creates an issue on this repo. I have a function which applies the labels to an issue, and it will just call the GitHub endpoint to apply the label automatically, right? But I want the LLM to classify the issue to say, hey, whether the issue is a bug or whether the issue is an enhancement and whatnot. So I'm going to make use of the LLM's ability. So here I have like asked the LLM, asked PromptQL to say, hey, fetch the latest GitHub issue, classify the issue as bug or enhancement, and apply the label to the issue appropriately, right? PromptQL will come up with the query plan. It will trigger the function, and it will execute that, right? Now, this is pretty good, but this is also on a UI interface over here in the PromptQL Playground assistant, right? I want to automate this outside of this interface, at which point I want to integrate this with a GitHub webhook for my particular repo. So we have an API which will execute this PromptQL program. So the fundamental blocks of this execution is this Python program that the LLM generates, which will also have the SQL query and the other classification tasks that are run inside that, right? So we are essentially going to just replicate this. We have the API. This is the URL, and you have the Python code that you need to execute, and you pass in the right headers as well for the user and the artifacts as well. So I have this Google Cloud function, which will be triggered whenever there is a GitHub issue created for the repo that I've configured. So this is just a web URL, and I have the PromptQL program API being configured here to be executed here. And what I'm going to do is I'm just going to like demonstrate creation of issue and applying the labels automatically through this call. I'm going to copy one of the recent issues from our GraphQL engine repo. I'm going to create this issue. This is my personal test repo. To test this out, I'm going to wait a few seconds, and we can see that the label got added automatically for this issue. So the classification task ran in the background in the webhook, and PromptQL just applied the label automatically through the GitHub endpoint. And we can verify that with our webhooks. So the webhook was just called here. The labeling just happened for this cloud function. Cool. So this will open up use cases outside the PromptQL Playground once you have access to an API. Awesome. So other smaller updates, we have a pre-configured LLM by default, so LLM key. So Hasura comes up with a built-in API key for the LLM. So instead of you bringing your own Anthropic or OpenAI keys, by default, we get started on a new project. You can choose to use Hasura, which is there by default. You get $10 worth of free credits, and beyond that, you can just add your billing details, and then you continue to use this seamlessly, right? So pretty good to get started for free, test out, evaluate before you can start your billing, right? So this is there by default for all new projects that are created. And just from a shareability angle, we have a couple of updates there, making a project public. For example, this GitHub example that I have, I have a simple README which will enable other people to try out this example. And I want to just share this project publicly, right? I can go to the PromptQL tab and just enable public PromptQL Playground, and I will get a PromptQL Playground URL, which is public. So anybody who has access to like a Hasura account or the Reading account, they'll be able to access this and try out your version of the project. So this is pretty good for sharing across different people outside your own space. And to top it up, let's say you wanted to like share this particular thread publicly, right? So we have something called a share a thread, which will just share it outside to the outside world. There will be like a public link, and this will work without login. This will just appear as a snapshot for anybody to just visit, right? So you can now use this to share interesting conversations, threads, or you just want to share it to the outside world on social media about a particular cool example that you just created. So these two are on the sharing side. And of course, big update with the support for PromptQL on private DDN as well. So now you can fully Salesforce PromptQL set up on private DDN on your own on-prem and whatnot. So that was almost the update that I wanted to share. Maybe there's few small UI improvements that we can quickly go over as well. We now have the ability to like download an artifact as JSON and then just start a new thread with that artifact, right? So let's say, let me take a different example where I have like a larger thread. Let's say I want to just start a new thread, just these two artifacts, right? And you can just download these artifacts and start a new chat thread, and PromptQL will use these two artifacts in its Python runtime, and then you can now ask more questions as follow-up. This will be useful when your thread size becomes longer and it starts polluting the context size, and you just want to like focus on a particular artifact and just want to like have the conversation, right? So just branching out from a particular thread. But yeah, that's mostly what I wanted to share. Would love to see people share public projects and like interesting threads on social media.
Praveen, that was awesome. Thank you so much. That's my first time seeing the sharing feature for threads, and that's really exciting. For some reason in my head, I thought that you would actually have access to querying within the thread, so I'm glad to see that's not the case. So if you share a thread, it's a read-only. That's very cool. Yeah. I know we've done a lot of internal projects and kind of little hackathon and things like that for PromptQL. Just curious, have you shared any threads on social media or LinkedIn, anything like that we could take a look at possibly?
Yeah, I think there are like a couple of public data sets that we have, and would recommend people to also try out with some Kaggle or Hugging Face data sets, try out some queries, share interesting facts.
Awesome. Well, thanks so much, man. Next up, we're going to bring Akshaya on to talk about multi-user SaaS integrations. Akshaya, how are you?
All right. Hey, I'm good, thanks.
Yeah, this is exciting to see that we're going to be talking about multi-user SaaS. This is my first time seeing this. And I've had a lot of questions in my mind around how this is going to work in terms of kind of like RBAC and that kind of thing with relation to PromptQL. So I'm sure people will have a lot of questions. And just as a reminder to folks on the call, if you do have questions as Akshaya is going through this, please go ahead and throw them in the Q&A section. We'll make sure that we answer them on stage at the end of this segment, but I'll go ahead and jump out the way and turn it over to you.
So we've seen how PromptQL helps you scale to larger data sets. We've seen how PromptQL helps you scale to more and more complex plans. And this is how PromptQL is going to help you scale to a larger number of users. So today, what we have with the DuckDuck API connector, which sort of helps us connect to external services. This is how it works. You have an external service like Zendesk. We bring that data into the DuckDuck API connector, which inside it has a DuckDB database. And then PromptQL sort of queries that, and the user interacts with PromptQL in that manner. So we saw two things. One is that a lot of people have been looking at our PromptQL demos, and they're very keen to actually begin to get their hands on a completely usable thing. Like we had a lot of interesting demos internally where people had put PromptQL on top of public data sets, like Hacker News or football data or IMDb. And we wanted to open this out to a lot of people so they can just jump in and begin using the product directly. Another use case we saw is that in a service like Zendesk, an organization can actually have many users using that. And Zendesk itself has permissions. So every user, depending on the role or group that they're assigned to, could have different permissions on the data in Zendesk, or different access to tickets, different actions that they can perform on. So how would we solve for these cases and bring it in PromptQL? So the simplest way of looking at this is to say, hey, I'm going to take my Zendesk data, all of it, put it into a DuckDB database, and then all my users are going to access data from that database. Now, this works great if you're okay with this permission model. If you're okay with all users accessing all ticketing information, which is fine for a lot of cases. But if you want to carry forward the permissions from Zendesk into the PromptQL setup, now that gets a little bit challenging, because then what you have to do is replicate all your permissions from the Zendesk system into the PromptQL metadata, the supergraph metadata. So how do we solve this, right? So the obvious way is, okay, so every user has their own deployment, where they have the PromptQL engine, and then the DuckDuck API connector with its own DuckDB database, and everyone just has their own deployment and they're talking to Zendesk. And so they can only see their own data and interact with their own data. But how can we make this more efficient? How can we get the setup to scale to a larger number of users? So this is what we've been building out. This is the DuckDuck API multi-tenant connector. And the idea is that every user has their own isolated and independent database that just is there just to hold their own data. And this allows us to guarantee that one user will never see or be able to interact with the data for any other user, because the data is completely isolated. So the idea is that the user would come in, they would provision their own DuckDB database inside the same DuckDB DuckDuck API connector, and then their data from Zendesk would be synced to that DuckDB database. Specifically, if we look at a single user over here, they would log into Zendesk using OAuth, get an OAuth token, and then that token is sort of used to isolate the entire pipeline for this user. So the user would send that token through the PromptQL engine, through the DuckDuck API connector to Zendesk, and actually it's the same token being used to sync all data from Zendesk into their own database. So in this manner, we ensure that every user's data is completely isolated. So I'm going to jump into a quick demo and see what this looks like to run it. It's very simple. We already have this Zendesk example working. So all you need to do is clone this repository, copy your environment file, change this subdomain over here to your own Zendesk subdomain. And then you're going to run these 3 commands to get your project up and running. I've already done that in the interest of time. And here you can see that my services are already up and running. The next thing we're going to do is go ahead and go to the console, where I'm going to head to this new OAuth Playground tab. I'm going to be able to configure different OAuth providers. So this is basically the first step where which enables me to log in and sort of get this token. So you can go ahead and add your own client ID, client secret, PKC is supported. And once you've done that, you're going to have something like this, which is a Zendesk provider. What you can then do is use this provider to log into Zendesk. And once you've done that, you're going to get an OAuth token. What I'm going to do next is say run. And what this run button is going to do is it's going to contact our PromptQL engine. It's going to contact the Duck API connector. It's going to provision your database and begin syncing your data. So I'm going to do that. It says starting, and then in a little bit, it's going to change into running. We can go ahead and look at what the logs are saying over here. So we have an init, and then let's see. It's I think it's already done the sync since I've been running it. So that's okay. So once this data is synced, then you can go into the PromptQL tab. And this again is completely scoped to your own data. So and then so this is actually live on our Hasura Zendesk right now. So I'm going to ask some questions. How many users are in the Hasura organization? Okay, let's see what it's doing. Okay. It's found 284 users, and it's also helpfully given us a table of all these users. So I'm pretty excited to get this going. I think this is going to be a template for how we build out our different organization connectors, different external service connectors, in a manner that also ensures that every user's data is secure and isolated, even within an organization. And this also opens up like consumer applications where we can have a single project running for, let's say, Gmail or Google Calendar. And different users can come in and without setting up anything, they can just log in and begin to play around with PromptQL on their own data in a completely secure way. So we're going to launch this Zendesk connector later today, so please watch out for that. And over the next week, please do also watch out for additional connectors and some consumer apps that are headed your way. All right, that's it for the demo. Thanks.
Awesome, Akshay. Thank you so much. I've seen that OAuth button on the PromptQL console for a little while, and I've been wondering, when do I get to play with this? And now it's exciting to see what it's there for and how it's being utilized. That's really helpful. Thank you so much. There may be some questions that come up a little bit after you come off, so just keep an eye on the Q&A section, and we'll get your questions answered. Thank you. All right, folks, we are approaching our last segment for today. It's going to kind of continue the theme that Akshay started with us just a minute ago, where we're talking about really third-party connectors and connecting to external services. We're going to bring Tristan on. So Tristan will go ahead and join me on stage. We're going to take a look at some interesting connectors with regard to Salesforce and working with customers. So Tristan, what do you got for us?
Yeah, hey Rob, how are you doing? I'm a
doing
little
well.
excited to share some of the stuff we've been doing. Unfortunately, I'm not going to be able to do a lot of live data demoing like Akshay was, because this is our internal Salesforce data. But
Oh, you don't want to share that publicly with everybody? Oh, okay.
Well, I don't know, maybe.
Just kidding, just kidding. All right, I'm going to get out of the way and let you take it away.
Sounds good. I'm going to go ahead and share my screen, and we will get started. So hi everybody. Today I am going to be talking to you about our latest internal PromptQL agent, which is our sales agent. So I'll start with an app overview. In our app we have 4 connectors. There's 2 Salesforce connectors, one for tables and one for views, and they both connect to BigQuery, which contains ETL Salesforce data. We also have a Postgres connector that connects to a database containing ETL'd Clari Copilot calls. With embeddings, we're storing using pgvector. Lastly, we have a functions connector that allows us to perform semantic search over our Clari calls. Let's see what kinds of things we can ask PromptQL about Salesforce. The PromptQL agent has access to the schema and relationships along with field annotations, so it understands the data sources it is connected to. If we ask which account has generated the most revenue, PromptQL will write some Python code to query the data and calculate an answer. Since this is our live sales agent, there's some data we've had to redact to maintain our customers' privacy. The agent queries the data and identifies which customer has generated the most revenue and breaks down where the revenue comes from, whether new business, renewals, or expansions. The most important part of the PromptQL process is the query planning. Notice how the agent will make a plan before it retrieves the data and constructs an answer. This yields massive improvements compared to using an LLM alone. We can ask lots of different questions to PromptQL. In the stored memory artifacts, we can see the retrieved data and even download it as a CSV or JSON file. PromptQL can identify the largest opportunities from our Salesforce data and tell us what stage they're in and other information like their expected close date. Notice how the query gets planned and lays out multiple steps before retrieving the data. The plan lays out which tables and fields to query, how to perform filtering, and how to sort the data. The next thing I want to show is how we use the Clari Copilot connector to ask questions about our sales call data. Before we jump into the examples though, I wanted to show a bit of code to explain what's happening behind the scenes. Whenever a new sales call occurs, we have background workers set up to ETL the call into our database and create embeddings that allow us to perform a cosine similarity search. We expose the ability to do a semantic search using functions. We annotate these functions with detailed information about what the functions can be used for and how PromptQL can call them. We've also set up relationships telling PromptQL that it can perform a join on the function response to the calls table to pull in additional call information. Under the hood, all that's really happening is a SQL query that utilizes pgvector to do the semantic search. So let's see some examples. The semantic search over query calls is really exciting and powerful. When I ask a question like tell me calls discussing Postgres, PromptQL can do a semantic search across calls to get the most likely to have discussions involving Postgres. Notice in the query plan how the agent specifies that it will use the semantic search calls by transcript function. It's thanks to this query plan that we're able to achieve this high level of accuracy. It's pretty cool, and I want to show some other examples that'll really demonstrate the value of this kind of tool. Imagine if you could ask questions like, in that call last week with ABC Core, who did we say needed to finalize the technical content? And have PromptQL look over the transcripts and give you an answer. Notice how the constructed query plan explains what the agent plans to do before it does it, similar to how chain of thought works. You can even use PromptQL to ask about PromptQL. In this case, we'll ask about any sales calls where PromptQL is mentioned. The agent is able to use semantic search to identify calls that mention PromptQL and summarize and provide details on the calls. We're focusing on the query plan again here, since that's the most important of the PromptQL agent. The answers PromptQL gives are accurate, but the focus is on the plan because that's what is allowing it to give those accurate answers. And I hope that if you take anything away from this, it should be that it's thanks to the query planning that PromptQL is able to achieve state-of-the-art accuracy and repeatability. You can try out PromptQL today, so connect and talk to your data and let us know how you're using PromptQL. And that's what I had for you today, folks. So I think that is just about everything. If Rob, you want to come back on?
Well, I'm back. Yeah, thanks, Tristan. That was great. One thing I want to talk about from your demo that you just did more than anything is that we've got data coming from different sources, right? And we're combining it together under this Supergraph kind of umbrella that we have. And while we're talking about PromptQL, really the underlying technology that's enabling all this to happen is Hasura DDN, right? It's that data delivery network that's a single semantic data layer that's bringing everything together. Could you just talk a little bit about kind of the power of being able to bring in these disparate sources and then ask questions on that data?
Yeah, I think it's funny because, you know, being here at Hasura, it's easy for us to forget the power of Hasura because, you know, we're so used to using it all day and every day. And, you know, we've got this DDN and it's, for most people, it's a shiny new thing. But for us, it's kind of already like, oh, well, I've been using that. But it really is so powerful because it lets you bring in pretty much anything, right? Like, you know, especially now with like our DuckDB connector and everything, it's like, it doesn't matter. You've got Parquet files in some bucket somewhere, pull them in. you've got Postgres, you've got Mongo, you've got a vector database, whatever it is, you can bring it in. And not only can you bring it in, but you can set up relationships. It basically solves the data loader problem, right? Where let's say I have something in one database and it's got an ID, and then I have something in another database that has that same ID, and maybe it's a vector, or maybe it's an AI inference model, or something where I can't keep them in the same database, right? Now I can take those and I can say, okay, well, that's fine. I've got one in this database, one in this database, but there is a relationship there, right? And I can tell DDN, hey, there's a relationship. And then PromptQL can look at that and say, oh, cool, well, I'll just take care of data loader for you. You don't have to worry about it. You don't have to do all the fancy joins. You don't have to worry about performance. I'll push it all down. I'll take care of it all for you. I'll give you optimized, efficient queries. And where we have to go to different data sources, I'll batch it for you efficiently. And so, it's almost like giving PromptQL this like power tool where we're saying, hey, we're going to give you the best query layer in the world to access your data. And so, when you talk about empowerment, right, like you look at our solution versus other folks, and it's like, well, we kind of have a little bit of like home court advantage in a sense when it comes to accessing data, I would say. So I don't know. That's my thoughts on that, Rob.
Yeah, 100%. And what I was driving at, right, is that ability to traverse kind of all these disparate data structures together into one unified graph, and giving PromptQL access to that is a great thing. And I'm going to keep Tristan on the stage actually for the rest of this, just because I have to wrap up the end of the call. And Tristan, you're going to stay with me because one of the things that we're going to talk about are the upcoming events, which I know you're involved in at least one of these. And if you folks can't tell, Tristan is our community engineer. He is our Hasura fanboy as well. You can find him every week in Discord, which I'll get to in just a moment. But right now, I have a slide up for our community calls coming up in February. Like we said, we're changing the focus on these. They're going to become more thematic. So come in February and join us. We're going to be talking about making your AI think before doing. And you can see a lot more about this idea of query planning in advance, and really making sure that your AI solution can actually think through things and come up with the best possible path forward, agentically like a human would, as opposed to just answering as quick as it can. Let's go to this next one. Like we said, HasuraCon is coming up live and in person in San Francisco in April. If you're on this call, I will see you there. Can't wait to be around all you folks. And those are some adorable new Hasura kind of little 8-bits that we have there. Those are new. Love it. We also have an event coming up. If you're in San Francisco in February, early February, we have a AI meetup happening in our office from 6 to 9 p.m. I know that there will be community leaders that are there. I think we have somebody from the organization Rippling. You can find more information on that QR code or at the site that's served by that QR code. I also know that there will be pizza and drinks. I hope there will be beer there. We'll see. And then finally, as I was saying, Discord office hours. Tristan, do you want to do a quick little plug for office hours for us? Tell us what it's like.
For sure. One thing I will say is sometimes I get lonely there because there's not always people that show up. So if you folks ever wanted like to get the inside scoop, if you want to, get help with something, maybe you're stuck, you can't get your container running, oh, there's a problem, you can literally drop in and spend an entire hour talking to me and I can help you. You can screen share, we can debug, we can jump into things. And, personally, I think not as many people take advantage of it as they should because it's not every day you can work with someone to get one-on-one personalized help. It's just every Tuesday.
And if we solve your problem quickly, maybe we'll play some GeoGuessr because that's become an internal company favorite.
There we go.
And,
I'll also drop a link as well to the event in the chat.
Awesome. All right, folks. As always, we're looking for feedback from the community. If you'd like to give us any, you can see that we have those options there, along with joining the Discord, which I think Tristan said he was going to drop the link into the chat as well. Let me keep going forward here. Thanks for joining us so much. We'll see you folks on the next one at the end of February. Have a great rest of your day, and thanks for joining. Bye.
Bye, everyone.